Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with some AP Physics 1 circuits free response questions. As usual, I suggest you pause the video and try to do the problem on your own, and then come back after you've attempted the problem. So a student is provided with a 12-volt battery of negligible internal resistance and 4 resistors with the following resistances. The student has plenty of wire and negligible resistance available to make connections as desired. Using all of these components, draw a circuit in which each resistor has non-zero current flowing through it, but which the current from the battery is as small as possible. Small as possible means I want the resistance that the battery sees to be as large as possible. And so I'm going to put them all, and the way I can do that is I put them all in series, like this. Because if I add, because to maximize the resistance, I would just add up all these resistances here, right? And then I would do V over R to calculate the current. Okay. Using all of these components, draw a circuit diagram in which each resistance has non-zero current flowing through it, but which the current from the battery is as large as possible. So that would be, to get the smallest resistance you can get is parallel, because parallel, when you add, it reduces the resistance. Make this 100, 30, 20, and 10. Okay. C. The battery and resistors are now connected in the circuit shown above. So I kind of have, let's see. Determine the following in the circuit: the current in the 10 ohm resistor and the total power consumption of the circuit. Okay. I like to think of it, when you're doing these kinds of things, it's useful to know which are series and which are parallel. Okay. So first, the current's going to come here, flow out of the battery. Oh, actually, did they want you to calculate anything on A and B? Let me double check. No, that's it. So back to this problem, I have current coming out of the battery, and then it has to split between here and here. Okay, and then it recombines up here and then goes. So all the current that comes out of the battery has to go with this. So this is in series with all of this. Okay, how about these? Well, these two are in series. So I can simplify this circuit to be 100 ohm, a 50 ohm combined, and then a 10 ohm. Okay. I know it's kind of messy of a drawing there. Now these two are in parallel because the current splits, and two, both ends of the resistances are the same between the 100 ohm and the 50 ohm. So then I can convert it into this. 100 in parallel with 50. You can either do 1 over, like, one way to do it is 1 over 100 plus 1 over 50. Or if you know how to add reciprocal fractions like this, the simple formula is you multiply the two and then you do the sum of the two. That's like a shortcut for it. Oops, plus 100. So this would be 5,000 over 150. So it should be 100. That's my calculator. I don't know the exact number for that. 33.3. 33. So then this, I can combine these two resistors to make a 33.33 because they're in parallel. And then I have a 10 ohm resistor here. And then now I can combine these by adding these two, because these two resistors are now in series, because all the current that goes through there will go through here. And so then I get a single resistor of 133.33 ohms. Okay, that's always usually the start. Now the total current that's going to flow is just V equals IR. So the I is equal to V over R. Okay. So that's 12 volts divided by 133.33 ohms. Well, it's not 133. Because this is a 10. This shouldn't have been 100. It should have been 43.33. Yeah. Plus 10 and then 12 divided by that. I got 0.277 amps. Okay. Now this is the total current that's flowing out of the battery. But it's useful to know that that current has to be the same current that flows to the 10 ohm resistor, right? because all of the current that comes out of the battery is just going to go through this 10 ohm resistor. So we have to say 277 amps. Okay. Now, total power consumption of the circuit. There's a long way to do this, and there's just an easy way to do this. The long way is to attempt to calculate the current through each resistor, or the voltage across each resistor, and sum up the power through each voltage and resistor. That's the long way to do the problem. It would be fine to do that. Be a little tedious. The quicker way to do this is to recognize that when these things, by conservation of energy, if these things use the power must have come out of the 12-volt battery. Because where did this power come from? It came from power from the battery. Well, what's the power in the battery? Well, power is always equal to I times V. So it's equal to the current coming out of the battery times the voltage across the battery. So that's 0.277 amps times 12 volts. And I would get 3.32 watts. Okay? So that's the faster way to do that part of the problem. And that's an important trick to recognize, that the power coming from the battery should equal the power drawn by all the resistors. Because the energy, it's conservation of energy, basically. Like the energy has to go somewhere, and it goes into the resistors. Assuming that the current remains constant, how long will it take to provide a total of 10 kilojoules of electrical energy to the circuit? Okay, so power is the change in energy over time. Okay, and if I want to solve for time, I could solve T is equal to change in energy over power. Well, the energy I want to provide is 10 kilojoules. That's 10 times 10 to the 3 joules. And I can divide this by 3.32 watts, how much power I'm delivering. So then we just do that. 10,000 divided by 3.32. I get it's about 3,009 seconds. Okay. So I hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch